Sorry I'm late. I hope everyone has a more delightful day than I've been having. Any questions? So I want to briefly mention the homework, that because it's a little different than last time. So you're going to have to get log into Canvas. And so I hope everyone has a login. If not, send me an email about that right away. Let me log into mine. And I'll show you what this is all about. Oh, Jesus. All right, let's see. So this is 151.04. I have to make myself into a student to make this. Actually, I think it's okay. So there's three parts to this assignment. This is both because it's good for you guys. It tests material that you should know, and also it's to help out my graduate student Sunita, who is doing her master's thesis on these programming exercises that teach. It's mostly intended for freshmen, but there's no reason that it has to be limited to that. So that's why we're doing it here. That teaches to become better programmers by solving short problems. So if you look at the homeworks that we're doing, they're kind of long and involved and complicated, and you have to take several days to get them going. But for simple programming tasks, such as in our situation here, just doing basic inheritance, there's no need to make them long and complicated. And so the theory is it's actually better to teach to do a whole bunch of short problems. And so this is done in a way that's kind of typical to test these things. There's a pretest to establish baseline performance. Then there is a bunch of activities, and then there is a post-test to see if the activities made any difference. So you're going to be the guinea pigs for that in this homework. The pretest and the post-test are timed. So from the moment on that you click, you have to finish them in that time slot. So set yourself aside, some quiet time where you can do that. Because otherwise it's not going to, if you walk away, there's no way of resuming later. The middle thing here, the practice thing, that one you can stop and start anytime you like. And there's no penalty for doing that. So you could just have a look at it, see what's involved, come back later, and all of that. And then the post-test is again timed. And so as you'll see when you see them, the pre-test and the post-test both do things with simple inheritance. So we want to know how much do you already know when you come in. Then you're going to be led through these activities, and then maybe you'll do better in the post-test, and maybe not. I have no idea. This is the very first time that we've been doing this. So you have to start somewhere, and I figured I'd start in a friendly environment and not in a class test somewhere with 200 students out at another university where I have no idea what's going to happen. So I'll be keenly interested in knowing what's going to be happening just in terms of the mechanics. If anything goes wrong, like a server is down or you just can't figure out what the heck you're supposed to do, just put a question on Piazza and we'll work through that. Now, looking at the schedule, since I did not want to mess with the sanctity of spring break, you don't actually have to do this until the Monday after spring break. But I'm kind of hoping that you could get it done earlier so that we get any bugs out. Yes?
Is there extra credit if we do?
If you could get it faster? Other than that, you can enjoy your spring break more. No. I don't know. I guess as you advance in your studies, the concept of extra credit kind of diminishes. So no, the extra credit would be that you'd be done with it and you can sip your rum drink or whatever it is that you're enjoying with more relaxation, or do whatever else you want to do. So it's just that because of this, the nature of this assignment with these timed exercises, it doesn't lend itself to do it in the last minute. So if you only start on Monday afternoon, you'd have to do a timed pretest, a bunch of exercises that could take you a certain amount of time, and then a timed post-test. I mean, maybe if you have nerves of steel, you can do that, but that's not my recommendation. So, and unfortunately, once you open the pretest, the clock ticks, and you can't do it again. So my recommendation is to do at least the pretest sooner than Monday after next. And then that could inform your decision what you do with the others. Yeah, all right. So if there's any issues or technical problems or anything, we'd like to know. So Sunita has been building this technology that puts all of these problems inside Canvas, which turned out to be a surprisingly challenging thing to do. And then, of course, she's now interested in seeing how it holds up with actual students. And that'll be her master's thesis.
When you say technology, is that kind of some kind of a framework or library?
It's hard. Well, so there is a kind of framework that all learning management systems share for integrating external activities. So when you're in Canvas, then you want to be able to do other stuff that's outside Canvas. This one here I can just do. It's not one of the timed ones. Come on. Oh, also, this probably doesn't work in Safari, so just use Chrome or Firefox. I forgot to make it so that it pops up in a separate window. Safari is fussy about it. So it puts these questions in here. And so normally what you can do in Canvas is that you can have a test bank of multiple choice questions. And that's well supported. But what they've never thought of is, what if you want to have like 5 programming questions in a homework? All you can do is make 5 separate assignments, and then you have 5 columns in your gradebook. And if you think of in our 46A course, they give 3 programming assignments a week, and then they have a draft and a final check-in. That would be 6 assignments a week. The gradebook columns would multiply like mushrooms and would just become totally unwieldy. And so what she has done is she's figured out a way on how one can aggregate multiple complicated problems so that they all fit into this little window. The scores are then kept at a database at a separate server, actually somewhere in the Google Cloud. And then when you finally say, save my work and record my score, I think all you have to do is saving is actually automatic, but it's there to make you feel better. When you click on record my score, then it gets transported from her external server into Canvas. And the communication between Canvas and these tools is of mind-boggling complexity. Whoever designed that standard, I don't know what they were thinking. It's one of those standards that makes the easy things cumbersome and the complex things impossible.
Is it an add-on Canvas?
There's a thing is called LTI, for Learning Tool Integration or some such thing. And yeah, if you want to have a truly bad time, go ahead and read through the LTI standard. And it is well-nigh incomprehensible. It took us a long time to understand what exactly we needed to do.
So you guys didn't modify the Canvas?
Well, that's the thing. We can't. We can. Canvas is actually an open source project, so we could download Canvas and mess with Canvas. But that does no good, because what's the chance of San Jose State saying, "Oh yeah, we'll be glad to run your modified Canvas"? Right. So we did need to have something that you can plug into an unmodified version of Canvas and whatever other universities use for theirs. So this stuff also works with Moodle and Blackboard, but it took a long time to get it to that point. So it is genuinely, an interesting piece of work. And as you see, when you do some of the other questions that are in here, some of them are just programming questions, and they're pretty simple. But there are also some questions that are not programming questions, and they themselves use another interesting technology. So those are all written in JavaScript. You'll see as you go through it, and then we can maybe talk about it when you progress through it and see if you liked it or you thought it was just pure drudgery. So she will likely give me a survey where you can give.
Is there any material that you have to review, or do we just take the test?
You should just take the test. You should know everything about it. Okay. So that would be my preference. The only thing is that there's a little bit of a backstory, so you kind of have to, you can leave this page open with the inheritance diagram that you might need to refer to. But you should really be just able to just totally do it with the knowledge that you have. And if that were to just be totally untrue, I'd kind of like to know. Well, there's 2 files that I have here, that for someone in 151 that should be pretty simple code. That's going to be kind of useful to look at. So I would look at those. I can't remember for my life whether they were used for the pretest. I don't actually think so. I think only the practice test needs them. But yeah, have a quick look at them. And it's all open book, right? In the 60 minutes or so, no one can prevent you from Googling something. But please don't do it in groups. I really would like to have everyone do it on their own, because what we're interested in is this basic approach of giving more practice in the small as opposed to practice in the large. Is that a valuable approach? That's kind of the point of her research. And so don't mess with her research. If in the end everyone says that was pretty hard, I'd be perfectly happy to do the scoring on improvement as opposed to on the raw scores. And if it was pretty easy, then everyone gets an easy score. Yeah. It's the timing part is the one that I'm particularly struggling with, because I know from the exams that I can do these things in 15 minutes, and then I could do the entire exam 1 in 15 minutes, literally. And then I see people struggling, and it takes students always much, much longer. And so I don't know, is the time that I allotted for these, is it adequate or not? We'll find out. And if it turns out it wasn't adequate at all, that's going to be super useful for us, because then next time we do it, we'll have to give more time. So, do it in the spirit of helping out a fellow student with her master's thesis. All right, that was that. Next, so just a few pattern questions here. So let me set up the clicker questions, and you contemplate this, just in the interest of learning to spot patterns better. Where's the general path? All right, let's see where we are with this. 19 votes. All right, so all right, so we have a couple of people who said this is an example of what, iterator, I believe. The vast majority said it's composite, and a few said it was a decorator. So let's just quickly see what's the general path. So general path, you can add rectangles and whatever other shapes we have, and then you can draw the whole thing. So the general path is again a shape. The draw method takes a shape as its sole parameters. And here you can see that we're also adding on shapes. So a general path has shapes. And that is really the hallmark of the composite pattern. A composite is something and it has the same thing. So the example of composite that we've had were swing components and containers. A container can contain components, and it is again a component, so you can stick it into an even larger one. So how do I know it's not a decorator? Even though those general paths are super decorative. Okay. How do I know it's not a decorator? For sure. So for that, we'd have to go into the description of the decorator pattern. And just as a tip, that in exams, it's usually easier for me to grade when it's not something, because it's easy to disprove that it's something. So here's the decorator pattern. And so here it would say the decorated object, indicating that there's only one object that's being decorated. But when you form a general path, there's any number of paths that can go in it, and therefore it's just a completely different context. Whereas in the composite pattern, here you have this notion of collecting other objects. Okay, so that again just as practice. So moving on to the next question. Rectangle 2D contains methods get x, get y, get width, and get height. And it does that because the x, y, width, and height, they could be in the subclass rectangle 2D.float or rectangle 2D.double. And then the contains method calls these methods. So what's that an example of? Votes already? Almost all of them wrong? No, just kidding. Ooh. All right, so here, these are a little bit more equally split. So there's 6 people who believed that it was the observer pattern. And it's easy to see, actually, that it couldn't be the observer pattern. Why can't it be the observer pattern? Why is there nothing here that would have anything to do with the observer pattern? Yes, excellent, right? So there's no list of event listeners, right? There's no one who registers themselves with a subject to be notified. It's just that's just simply not there. We just have that contains calls get X, get Y, get width, and get height. So I was glad that not too many people thought it was the strategy pattern, because so what I said about, just because it seems strategic, don't say it's strategy, that seems to have caught on with many people. So it is in fact an example of the template method pattern, and we'll talk about it later in the lecture, because I want to do that one more time in slow motion. All right, and so this one is a little different, doesn't have anything to do with patterns, but it has to do with exceptions and the exception hierarchy that was discussed at the end of the chapter. So here I have a method that throws an I/O exception, and that's kind of common for a read method, right? With a read method, you don't want to have to catch all the exceptions. You just want to have it thrown out so that a competent handler can deal with it. And now I want to form a subclass of this method, and in the subclass, I want to override the read method. So maybe this is employee read, and I want to override this with like a manager read kind of thing. And so my question is, which of these is true for the exception specification? We're getting on a vote on it. All right, here we go. All right, so there's a lot of people said none of the above, so we'll look into that in a minute. And then the second most popular option was the second one. So, and I can see the attraction of the second option, right? That you say, well, we're forming a subclass, so surely this thing must also be a subclass. So, not many people favored one, and so I guess everyone does seem to think that it should be okay for read to vary the exception specification somewhat. Maybe it can be more general, or maybe it can be more specific. Now, let's look at 3. So 3 would suggest that it should be okay to change this thing to public void read throws exception. Right? That's a superclass. Where we say, oh, this method can throw any exception at all. Why can't that be right? In 3 words or less.
Law of substitution.
Yeah, exactly. The list of substitution principle, right? And so the reason is that that if it was permitted to throw more general exceptions, then substitution would not work. so if you have a context where it says Fred.read, and this is his subclass, then in this context, the compiler assumes, well, maybe there's an I/O exception, but I know for sure there's not going to be some other checked exception. But if you now were able to say new subclass, and the subclass was actually allowed to throw something else, then the exception checking would work. So because of the substitution principle, we know that 3 must be wrong. So we still think that means that 2 must be right. So who said none of the above? Why?
Me?
Yeah.
I mean, you could like write anything. It doesn't have to be the same place. It doesn't have to be from like an input stream. So it doesn't have to have an exception.
Aha! It doesn't have to have anything at all. And
That's why you were writing.
that is correct. So that was my reason to put in 4 as well. Because, what if the thing just doesn't throw an exception? It's perfectly legal to implement it and say it doesn't throw any exception. Yes, and so 4 actually, you can argue, is that is like no exception, like a special case of this, or 4 would both be correct. Right? With 4 meaning that it's okay to have no exception specification at all. So if you have an exception specification, then it should be, so 2 and 4, right? 2 and 4. So if you have an exception specification, then it needs to be a subclass of I/O exception. So for example, you could have, what's a subclass? A file not found exception, right? If this just throws a file not found exception, perfectly fine. It's weaker than throwing an I/O exception. And if it throws no exception whatsoever, then you don't have this thing at all. Then you have your 4, and that's also. Yes?
So when you say when you don't put that it throws anything, does the compiler assume that it just throws an I/O exception like it's super?
No. At that point,
it just says that it throws nothing at all.
It will check. It will check that the subclass read method will in fact throw no checked exception.
Oh, okay.
It will locally check that because you might be in a different context where you say subclass. And then if you say Peter.read, now you've made a promise that it's not going to throw anything, right? And so the compiler will enforce that. All right, that was that. Let's go through these slides fairly quickly. Here we go. So last time, just as a reminder, we had this somewhat hokey set of examples where we want to be able to select shapes. Why do we want to select shapes? Because I want to have something in that abstract superclass that requires an instance variable. So the abstract superclass has a field for. Yeah, sorry, I still forgot to fix this. So it has this field here of this Boolean is selected. It's an instance variable. Do I have a diagram? Here we go. So it has this instance variable here. So it's an abstract class, and it can't be an interface because of that. And the way the selection was done is with this draw selection method. And the draw selection method just draws some arbitrary stuff to show that the various shapes are selected. So the car highlights this thing if it's selected, and the house highlights that thing. But that's actually kind of a dumb way, and no one would do that in an actual graphics editor. So the kind of thing that you more commonly would see is that something that's selected would kind of draw itself, like it draws itself fatter. Now, how is something like that done? It's pretty simple. What you do is you take this thing and you move it a little bit to the left and draw it, and you move it a little bit to the right and draw it. That way you fatten it up. And so let's look at the code for that. So I've put that here. I've now moved the draw selection into the abstract class. And so it calls translate for the moving. drawing, translate, drawing, and then it translates it back again. And that way it draws that flattened declaration. Now, what's somewhat remarkable about this draw selection method is that it calls translate and draw. Where are they defined? Obviously not in here, right?
Scene shape.
So let's see, in scene shape, do we have scene shape here? Let me run Eclipse. Well, while it's loading, tell you, and then I'll show you that in scene they've declared, but not defined. Here they are, and you see there's no definition for them. Declared the code and select. Without the declaration, I would have no method. But they're not defined here. So we're defined. In terms of other methods that are themselves completely defined, they're abstract methods. But it does something fairly useful. It has this general mechanism that says to draw the selection, we smush this thing up in this way. And so it's interesting that you can do this, that you can do useful work out of nothing by simply composing a sequence of undefined operations. Later, of course, an actual shape does have to define all the undefined operations. So if you look at car shape and house shape, they, of course, define what it means to do drawing, this messy set of drawing operations, and what it means to do translation, namely to adjust their top left corner. And the same thing with the other shape. There's a draw, messy drawing, and there is a translate, adjusting the top left corner. So ultimately they do get defined, and it's perfectly safe to call them. But it's interesting that you can do this, and it's something that happens not just once, and so that's what this pattern here is for. So the template method pattern says that you have an algorithm that's applicable for multiple types. In our case, the fattening up algorithm is applicable for houses and for cars and for whatever else. And now the most important part is that the algorithm can be broken down into primitive operations. In our case, the primitive operations are translate and draw, with some arguments in some well-specified sequence. And the order of the primitive operations does not depend on the type, meaning that with a car you do translate, draw, translate, draw, translate. With a house you do translate, draw, translate, draw, translate. And so the sequence is completely generic. So when we have this context, then we can do the following. Then we can, in a superclass, put a method for the algorithm, or I guess in Java 8 it could be a super interface. So here we have the method for the algorithm that we want to have. Here we have the implementation of the algorithm in terms of the primitive operations. Each of those are abstract. They've been, in this case, inherited from the abstract supertype from this interface. So we implement the algorithm to call the primitive operations in the appropriate order. That's what you see here. We don't define the primitive operations in the superclass. So neither translate nor draw are defined here. They're abstract. But the subclass defines the primitive operations, and now the subclass does not define the algorithm. The subclass does not define, in our case, draw selection. And if you look at car shape, there will be no implementation of draw selection. It just inherits that generic thing. So a method such as draw selection is called a template method. It's a method that it's kind of like cookie cutter, but what it means for each of these individual steps, that is undefined. So what's the difference between template method and strategy? So as a recollection, the easiest way to see strategy is probably sorting with the comparator. Right? The comparison strategy is given by the comparator. And so if you think about sorting, it's kind of a similar thing, isn't it? That what you do is you loop through an array, you take two elements, you compare them, and so the way in which it's compared, that's something that we want to have some control over, but the basic flow doesn't depend on the comparison. So it seems that they would be very similar, but what's the important difference?
The strategy makes the classes do all the work completely.
Well, I'm not. That's true, because I mean the basic work is done here, right?
Yeah.
And so you've had the other place where you've had strategy, of course, was with the last homework, right? And so what was characteristic about the last homework? What did you do with the strategy? You had a couple of strategies, and then I had another strategy that I supplied in mine. How was that strategy supplied to the algorithm? Yeah?
In the strategy pattern, actual strategy classes realize this interface type, but here it's all abstract.
Well, someone at some point, okay, so let's say we would want to view both translate and draw as things that need to be done with strategies, just to see if the strategy pattern can be made to work. But in a strategy pattern, how do you supply the strategy?
As an object?
As an object. You make the object, you hand the object to the algorithm and say, hey, use this strategy as embodied in this object. So in this case, if we could make the strategy pattern work, we could give draw selection two parameters, one translation strategy and one drawing strategy, and then some external object would have to come in, and we would have to invoke that. But that's not what we're doing here. Here we're supplying the correct versions through inheritance. We're saying the subclass must put them somewhere inside itself. They're not external objects that are being applied. And so each of them has its value. The strategy pattern is more general. That if I really wanted to have different strategies for translation and drawing, then I could pass any arbitrary things in. I mean, remember, I had some crazy strategy for movement in the last homework, but it could also be quite cumbersome. If you don't actually want that generality, then it would be really tedious to have to pass in these functions every single time. So the template method is when the subclasses naturally have these primitive operations anyway, probably because they need them no matter what, then having the template pattern just makes it very easy. All right, so that's the template method pattern. It's a common pattern just because it is a convenient thing to be able to do. And so if we look at, let's see if I have this. No, I wish I had this. But I'll show it with this one here. So what we've done, look at this diagram here. By using the template method pattern, we were able to take these things here and move it down here. And that's nice, right? We were able to take this method and give it a common implementation. But the cost was that I had to translate here. No, there was no cost because I already have drawn translation. So that's a nice thing to be able to do when you can. That you realize that really the same mechanism can be applied at one level higher, and then no one else has to worry about it anymore. All right, that's the template method. So the next example here is there for a different reason, and maybe not a great one. And I'll just show you in the code, and then we'll skip past it. I guess I'm not going to show you in the code. So here's what we're doing is we're making compound shapes by using general paths. I really do want my code. Okay, but I don't have it. Okay, so we're making these compound shapes by using general paths, and then at some point we want to be able to access this general path object that's declared in the superclass, and that's this one here. So the compound shape here wants to store the path object, and then house shape wants to access it. Now that's against all the rules because anything that's an instance variable in here is private. And so some people believe that it should be possible for a subclass to access some features of the superclass through something other than the public interface of the superclass. And so they've cooked up this separate mechanism called protected. And so in this case here, we've made this method compound shape add a protected method. So that's the method that would be on this level here that adds to this private general path here. We made it a protected method so that a subclass can call it, but that others can't call it, like to add graffiti to a shape. And it's an exceedingly subtle point that you now have kind of two interfaces, one for everyone and one for just the subclasses. It's also one that's not very commonly used because in Java, weirdly enough, protected means something that's different from what it means, say, in C++. Protected means that any subclass methods can use it, and also any methods in the same package. And that opens it up pretty widely. And I think in the entire Java API, I'd be surprised if there were, there's tens of thousands of methods in the API. I'd be surprised if there are more than 100 or so who are actually protected. So it's not something that I have never in my own work had to use it. But it's there's one point where you need to understand what protected means. So the general idea is that whenever you see protected, you can probably take a pass on that. It's not something that is greatly used or that extends the expressive power of the language. Probably its single most important use is in job interviews. But it is there. We will see a method called clone fairly soon that is protected, and we will need to know that we need to unprotect it. We need to make it public so that the general public can use it if we re-implement it. And that's really the only reason I put it in here. The other reason I put it in here is that people who adopt the book think that it's a feature, so it must be discussed. So I don't want to say too much about protected. So then at the end of this chapter, there's a whole bunch of hierarchies of components just to show that inheritance is ubiquitous. Here you have the hierarchy of swing components. Here you have a hierarchy of geometrical shapes that I'll come back to in a minute. And here you have the hierarchy of exception classes. And so when you have any kind of toolkit, it is fairly common to use inheritance to layer these classes with the most general on the top and more specialized ones on the bottom. And so that's not very surprising. So the one thing that I do want to say that it's not in the book is that when people learn object-oriented design, they learn about inheritance. It's a complex mechanism. And they almost immediately start overusing it. And so it's very common for beginners to see inheritance in lots and lots of places. And while it's true that it has its use, it's actually much less common than you would think. Interfaces are super common. Interfaces are very, very useful to abstract out implementation from specification. But inheritance is not as common as you would think. And so you should not reflexively model everything with inheritance just because you can. So really ask yourself, am I having a situation where I have an already existing implementation and I want to specialize it further? But the poster child for inheritance is certainly something like this. The Swing classes or any user interface toolkit classes where on the root you have like a generic component where you then, as you further go down, you have more specialized component, a JText component here deals with text. And then there are two kinds of those, a text field and a text area. So you can push up a method such as getText, setText up here. But things that have to do with rows and columns would only work in the text area and not in the text field. One weirdness that you see here in the hierarchy of Swing components, so we have a component, we have a container. That's the composite pattern network. A container is a component. And then there is a J component here. So what happens is that at one point we only had a very primitive toolkit called the AWT. Then Swing came along, had the fancier components, the ones that start with a J, J component, J label, J panel, J text field, and so on. And they wanted to build it on top of the existing structure. So why does J component extend component? Why does it extend container? So when you look at it, a button, a J button, is a container, right, through a chain of inheritance. And you can actually call add on a J button and add another J button inside the first one. It doesn't show up. It doesn't make any sense to do it either. But it will compile. Why did it do it? So here's what they wanted to do. So the stuff that you see here is the old stuff. So what they wanted to do is make J component extend component. And then they would have had to have some class like J container. And so a J container would also extend component. And then a panel would just extend J container. Yeah, this is what they would have liked to do. And of course, a J container would also be a container. Then here you have a J container is a J component, that's the composite pattern. And the rest is just standard inheritance. Why didn't they do it? Excellent. Yes, you cannot extend two classes here. It's illegal, right? And so they couldn't do it. And so the problem was, had they done this nicer so that these things had been interfaces, would have been no problem. You can extend to interfaces. But component and container are pretty heavyweight things. They contain a lot of implementation. So that was not something that was easy. And anyway, those had been 2 years older, so they were loath to change them. And so the only reason that J component extends container is that A, by history, these things already existed, and B, Java does not allow multiple superclasses. Other programming languages allow that, with a lot of complexity, but Java does not. So that's the little history here. Okay, so that we do a little bit of actual stuff and not just look at these slides. I have one assignment here. So look in your textbook. There is a problem 17. Let's quickly find what that was. And I want you to do that with your buddy. It's that should take a few minutes, and then we'll discuss how it goes. 17. All right, so what I want you to do is make the draw selection a little bit different. And instead of messing around with fattening up the shape, I want you to draw a little solid square up here, a little square here, in each of the corners. So if you have some shape here, like a car. So the idea is that you take the bounding box, which the shape would need to give to you, and using that should give you all that you need to draw. So start out with that Scene 2 project. And let's make a copy of it. It's probably best not to mess with the original. So start with chapter 6, Scene 2. So I already made a project of it. And I hope you did too, because like I said, it's always a good idea when you read the book to actually run the code. So I'm going to paste this in here. That seems like a good name for it. At this point, I would place this in the default location. That was actually not so clever. Let me do this differently. Because who knows where the default location is. Let's delete that. So here's what I really want to do. I go into my CS151 directory, a make directory for this lab. Which lab do we have? 14. Here's 14. So this is ODP3 code, CH06, Scene 2, store, lab 14. And now you see in lab 14, now I have all my code. And now in Eclipse, we can get it from an existing directory. Lab 14. And here we have it. So now here we want to call getBounds. But I'm getting a wiggly underline. Why am I getting a wiggly underline? See what it says. The method is undefined. So the quick fix is to create it. Where should it be? I think so too, right? That seems reasonable that each shape should be able to have its bounds. Okay. So now I did that, and now I'm getting ugly marks here on car shape and house shape. Why? I didn't implement getBounds, right? How the heck do I know the bounds of a chord shape? So check out contains. So contains checks whether it's between x and x plus width, and y is between y and y plus width over 2. That looks like a test for whether it's inside a rectangle, right? So it's a good guess that that's probably the bounds. Let's see if we're as lucky in the house shape. Yeah. This. So now what do I do? Now I have the bounds. So how do I draw this now? Oh. Nice, you can always. That was it? How do I draw the next one?
Do it at the x plus y.
There's a nifty method, get max y, that gets me the largest one. And then I guess I can do that. Okay, and this shows the power of programming by wishful thinking, right? That now I've found this method that I need to implement. So what does it go? Is this ins or doubles? I think they're doubles. Oh, I need a G2. So to draw, you always need a graphics context. So I need to pass it in. So what is it? Fill new rectangle. Double x minus gap side over 2, y minus side over 2, side. I know, 4. And I didn't pass G2. That didn't work at all. Oh, because I'm not running my project. And here you see the grabbers. Okay. So, is that an example of the template method pattern?
What's the logic with the final X slide 24?
Oh, well, I want to have it centered around. So I want to draw these things, right? So I'm given the center point. So if I blow it up, here's my bounding rectangle, and I want to draw this thing. This is the center point. And so now I need to draw fill a rectangle that starts, so this thing is side. And the x value that starts at is the one that I have minus a half the side. And then minus a half the side in this direction. And then these are the width and height. Okay, so my question was, is this an example of the template method pattern? Before it was, when I had the calls to translate and draw.
Now you're doing the fill tiny square.
Well, I don't think the fill tiny square has anything to do with the template method pattern because that's not an abstract method. That's the one that I have in here. What about get bounds? Is it abstract? It's abstract, all right. We defined it somewhere in scene shape. Here, right? It's defined. It's declared but not defined. And the concrete classes, so the house shape and the car shape, they do implement it. So it is kind of like translate. Translate is abstract and scene shape, and it's implemented with those concrete classes. So the question really then is, the template method pattern said there's primitive operations, and we use the primitive operations to make the compound thing. In this case, we just have one primitive operation. And so I think that's a bit up to, you could say, one primitive operation is a primitive operation. So I think it would be okay to say it's the template method pattern. It's not the most convincing example that I've ever seen, but you could argue that it's not so dissimilar. Just need to make sure that you understand that get bounds is the primitive operation, and fill tiny square, as primitive as it may be, is not a primitive operation in the language of the pattern, because in the language of the pattern, the primitive operations are abstract. Right, and this one here clearly is not. So here we're taking a primitive operation and some other work that's nothing to do with the pattern. So going back to this one more time, remember how in the car in the house, how I peeked at contains, and out of that I got the implementation for get bounds. I simply looked at that x and y were the lower and x plus width, and then the y plus 2 times width were the upper ends, and then out of that I cooked up this rectangle. Now that I've done that, in both the same way for car shape and for house shape, just so that you can see in car shape I did the exact same thing. I took the components that I got out of contains and put them into here. What can I do about contains?
And you can use the contains method of rectangle.
Yes. So now what I can do is I can ditch contains. Also in the house. Now when I save, then I should be getting a complaint that they no longer implement contains. So where can I implement contains? So there's two levels above. There is the scene shape, and there is selectable shape that has like that thing for the selection. But I think I can actually do it in scene shape, because over here I can say return get bounds contains P. Right? If I say the shape contains, if the bounds contain it. Why am I getting wiggly underlines?
It's an interface.
Very good. It's an interface. Yes. So I have to add default in front. That's just an evolutionary thing. And now works just fine. Someone is not happy with this, they can still override if they want to have really track all the nooks and crannies of their shape. But here we have the basic thing. Is this an instance of the template method pattern? Yeah, kind of, right? Same thing as before, that we are having one abstract method, and out of that abstract method, we cook up this algorithm. All right, well, that gets us to the end. Thank you very much.